Okay, so the first thing we are going to look at is overview of ICT. When we say ICT, what do we mean? Now, ICT is more like acronym: information, communication, and technology. There are three words coming together to form that word ICT. So what we are going to look at is, when we say information, what do we mean? When we say communication, what do we mean? When we say technology, what do we mean? So I want you to look at ICT in this way. Communication is the core concept of ICT, because communication means passing information from one point to another. So let's say, as we are doing now, I'm passing information from myself to yourself. That's information. Now, that's communication. The concept of passing information from me to you is communication. So now, what is that thing that is aiding us to pass this information? For example, if you are not connected to internet, you won't be able to hear me speak. If you didn't have either a smartphone or a laptop, you won't be able to hear me speak. So those are the technologies that makes up communication, that makes up information communication technology. So it's the technology that we use to pass information from one point to another. It's the technologies we use to communicate. So by definition, we say ICT is the technology required for information processing. So it means for me to process information or to pass information from one point to another, I need a technology. Without that technology, it won't be possible. So before now, there had been different forms of technologies. We remember when we used to use landline, where there will be a cable connecting cities together, and you stay at one point and make a call and dial, and what actually happened is the information will pass through a cable from one point to another, maybe from one city to another. That was a communication medium. That was the phone becomes the communication technology. So that's how ICT works. That's what I would call the layman's understanding of ICT. So when you hear ICT, just think of it as the technologies, sets of technologies that powers communication, set of technologies that aids you to move information from one point to another. So we are going to look at it in details. We look at information. What is information? Information refers to the knowledge you obtain from reading, investigation, studying, or research. So what that means is, as you're sitting at the other end and then listening to me, you're getting information. So that's information. I want us to hold that one there first. Communication is the act of transmitting message. And then technology is the use of scientific knowledge. So now I want us to stop at this technology. We said information is you hearing me now is information. Now, technology now becomes whatever you use to hear me. If you're just sitting in your house, let's say all of you are miles away. If you're just sitting in your house without an internet connection, without a mobile phone or a laptop, there is no way you would be hearing me speak from miles away. So for the fact that you made use of computers, internet to hear me speak, that's the technology that powers the information. So that's a brief explanation of information and communication technology. So the central concept of information and communication technology is computers. And when we say computers, we don't necessarily only mean that desktop sitting in your office or the laptop in front of you now. We mean everything that you can use, all electronic devices that you can use to store information, process it, and send it out. For example, your phone is a computer, a form of computer, because with your phone you can store, you can take input, you can type something which is an input a form of input. You process that thing, maybe you type 1 plus 1 and process it, and it gives you 2. So it does the 3 things that makes it a computer. And the 3 core things that makes a computer is its ability to accept information, its ability to process that information, and its ability to give out that information. So ordinarily it's supposed to be like 4 steps, but the known ones are 3 steps. Now the 4th step is the ability to store information. That one is there but remains kind of silent. So the key thing that makes a computer is it accepts information, processes it, sometimes store it, and then send it out as output for you to see. So when you open a Microsoft Word and then start typing and you arrange it and print it out as a letter, that's computer doing its job. So that's the basic explanation of computer. So let's look at the detailed explanation. A computer is an electronic device operating under the control of instructions stored on its own memory. Now, this explanation, I don't want this explanation to be confusing to you, but I just want you to, because we are going to look at instructions, we are going to look at memories, we are going to look at input, we are going to look at process as we go. But what I want you to understand about computer is any electronic device that accepts data, processes it, and then give out result. Okay, so let's go to look at some of the functionalities I will talk about. Now, what makes a computer, like we said, is its ability to take inputs, its ability to store and process that input, and its ability to generate outputs. So if you don't remember anything about computer, or if you see an electronic device and you're not able to differentiate if it's just an electronic device or if it's a computer, 3 things you should look forward to, you should look out for are: does it accept input? Does it process it? Does it give output? Does it store that? So now input, when you're sending input, it's called data. It now processes data into information. So what you get is what you put in, is what you garbage in is data. It processes it and gives you back information by way of output. So please, if you have any question as we are going, I want us to move a bit faster, so I will start being a bit faster. If you have any question or anything that is not clear, you can always call our attention. We can pause and explain to you, because the whole essence is for you to understand it and understand it well. Okay, so let's proceed.
I have a question. Good evening.
Go ahead, please.
Hey, good evening. Hey, you said that a computer is any electronic device that can accept data as like input. Then I want to ask, is calculator also a computer? Because they accept data too. If you press in like 2 plus 3, it will bring out the output. So are they still computers?
Okay, yeah, that's a good question. So computer is classified as some form of computer. Now, we may not have the time to look at the generations of computers. You will see how computer evolves, even from the age of abacus. Abacus was a counting machine that makes use of something like how do we call that? Crystal balls to do counting. So, but it evolves from there and keeps changing to the digital, to the age that we are now. So yes, a calculator is still classified as a computer, though a form of computer, which we may talk about it along the course of this. So types of computers.
Thank you.
You're welcome. This might not be very necessary, but then there's no information that is lost. So we have personal computers, we have mainframe computers, we have mini computers, and we have supercomputers. Let me start with supercomputers. Now, for the fact that you're able to use Facebook ever since Facebook came out, I want to use Facebook as an example. For the fact that you've been able to use Facebook ever since Facebook came out, and there are billions of people on Facebook uploading pictures, putting content, and this thing still survives. Now, with those level of content, your regular computer cannot survive, because number one, your regular computer, you cannot afford to keep your regular computer on maybe year in year out without putting it off. Number two, your regular computer has limits as to how much information it can accept at a time, how much information it can store at a time, how much information it can process at a time. That's where supercomputers come in. So now there's what's called like server farms. Most of the big IT companies have server farms. So they call it server farms, but I want to anytime you hear server farm, what I want you to understand is a location where there are supercomputers, more than one supercomputer. They are all stored there, they're all working. Someone is interrupting my screen. Can you turn off screen sharing? Rachel, thank you. Okay, so I was explaining supercomputers. So now those computers are there 24 hours a day, 7 days a week, 365 days a year. They are running. If something goes bad, it can be swapped. Like it's there's what is called hot swapping. That is changing components while the computer is still running. So those are example of supercomputers. Then mainframe are those computers, something similar to supercomputers, but the difference would be that supercomputers could be, okay, for example, like them Facebook that are big, they can be using supercomputers. Then mainframes are equally super, but not as large as supercomputers. Then the next one is the mini computer, and then we have the personal computers. Example of a typical mini computer could be like a POS machine. When I say POS machine, please, not the POS that we use now to put in card. There's what's called a point of sales machine. Mostly you see it in superstores and pharmacies. Yeah, those are examples of mini computers. And then personal computers, what we call PC. We all understand these ones. The laptop on your desk, the desktop on your table, they're all classified under personal computers. Now, though under personal computers is now broken down into your desktop, your laptop, your tablets, and all of those. Those ones are still personal computers. So let's proceed. Okay. So this is a typical information of all of those. A typical picture of all of those, representation of all of those. So we are going to look at parts of computers. Now, computer is mostly called computer system because it's a combination of components coming together to function as a system. So when we say the body system, we definitely means it's not a one person do it all. It's a combination of everything. So like your body system, you have the eye, you have the nose, all of them are performing their functions. One might not work well without the other. The same thing in computer, and that's why it's called computer system, because many components come together to form a system, to work together to form a system. So as part of computer system, we have the hardware and the software. The hardware are the physical thing you can touch and feel. The software are those ones you cannot touch and feel. I would really want to put like 3 minutes on software, but at least hardware, you all know hardware, that you can always touch it and you can always feel it, and what you're carrying is the hardware. So typically this is the pictorial representation. We're going to look at all of this monitor, modems, and all of those, but my concern is software. What I want you to really understand is software, because there's been a bit of confusion on what software is and what software is not. I am trying as much as possible not to teach a computer science class, but I mean, it's still an information that you will need either to make decisions or to just know it as knowing. So now when we say software in computer, software are sets of instructions. So I want you to look at software like this. Don't look at software as one mystical thing. For what, that's why I want to use the next 2 minutes to try and break it down. So I want to use a typical example. If you have a child and the child is at home, and yes, the child can hear you, the child can process whatever you say and understands what you say. Now it's now left for you to now start giving the child instructions on what to do. For example, okay, baby boy, I'm going out, so if anybody knocks, if you hear any knock on this door, ask the person, who are you? If you don't hear any knock, don't say, who are you? Now that's an instruction that you've given to that child. So let's say someone comes and knock on the door. The child now said, who are you? The child is performing the instruction that you gave the child. Now that is software. So what you've done is you've bound a copy of a software to that child, giving him instructions on what to do and how to do what needs to be done. Now that's exactly how computer works when we say software. So your computer now, after the manufacturer have manufactured the keyboard, the screen, and power to power all those components, someone now sat down to write instructions. And these instructions, I want you to first off see these instructions as written in normal language, just as you can write instructions. Okay, instruction number 1. So the instructions could be, okay, instruction number 1, if anybody press the power button, act this way or show this light. So that's where when you press the power button, it comes on and starts loading. So it's performing the instruction that was written and stored on it to perform. That's what I want you to understand as software at all times. Software are sets of instructions that makes the computer perform tasks. It's what it tells the computer what to do at any particular time. And then this software again is broken into two: the system softwares and the application software. Now system software are, so when you buy, for example, when you buy a new laptop, mostly it comes with an operating system, a system software. We call it operating system. For example, if you buy a very much new laptop, it will come with Windows 11. As of today, it will come with Windows 11. But we have other Windows. We have Windows 10. We have starting from Windows 7. We have Windows 7. We have Vista. We have Windows 8. We have Windows 10. And then we have Windows 11 as of today. So those are system softwares. So it means they are general purpose softwares that is designed to give the hardware of the computer instructions on how to behave. Now, those softwares are not there to perform any tasks for you. Their task is to direct the hardware on what to do. Like for example, when you close your computer in most systems, it goes into hibernation or sleep mode. That's a system software at work. When you press a combination of Control C, it copies whatever you want to copy. Control V pasted will now paste it on wherever you want to paste. That's the concept of a system software working. So now we look at another angle of software called application software. Application softwares are those add-on softwares that are added on top of the general software, on top of the system software, that will help you perform specific tasks. For example, that you are able to join Zoom call is by way of the fact that you have a Zoom application on your phone, on your laptop, or you're using the browser. Those are application softwares that you can use. Microsoft Word. Microsoft Word is an example of application software. So those softwares that you can install as add-ons on your computer to help you perform specific tasks are called application softwares. So let's look at some of the system softwares. Like I said, when you hear operating system, know that you're hearing about system software. When you hear system softwares, you're hearing about operating systems. So let's look at some of the common operating systems. We have the Microsoft Windows, which is predominantly available across. No, they're having a match now. Their match is Mac OS. Mac OS is almost matching Windows at a very high speed. But then Windows is that system software that anybody at any time knows about. So we have Microsoft Windows, we have Linux, we have Unix, we have Mac OS, and we have DOS. DOS means Disk Operating System. Okay, so these are the types of operating systems, types of system softwares. So since you're not writing a computer science class, we'll pause there. But just in case you're writing a computer science class, now we have different variants of each of these softwares, and people mostly get confused between variants of a particular operating system and the type of operating system. So for example, if you have Windows XP, Windows 7, Windows 8, Windows 10, Windows 11, those are variants of Windows operating system. They are not types of operating system on its own. Then you have, like, in case of Mac, you have like on different version, Mojave and other versions of Mac. Those are variants of Mac operating system, not types. So we proceed. We've talked about application softwares that is used to accomplish specific tasks other than just running the computer system. Computer units. So now computer unit is made up of 5 key units. Whether you're using a laptop, whether you're using a desktop, these units apply. It has to have input unit. For example, let's use the laptop. The laptop you're using has a keyboard, which forms part of the input unit. It has a mouse, which forms part of the input unit. Then the computer will always have the central processing unit. Now, in the case of a laptop, the central processing unit is built in to the laptop. In the case of a desktop, you will see a box sitting separately called the CPU. You see another box sitting separately called the monitor. You see the keyboard sitting separately, and you see the mouse sitting separately. But in the case of laptop, all of those are bound into one. But it doesn't mean that they are not still, the concept still applies. Your laptop has an input unit, which for example is the keyboard, the mouse. The central processing unit is embedded into it. The primary memory is embedded into it. That's what we call RAM, random access memory. The secondary memory is embedded into it. That's what we call the hard disk. The output unit, the screen that you're looking at, what's happening, forms part of the output unit. So even your laptop, your palm top, they have all of these 5 units. So I want you to understand the 5 units. So we proceed. Let me use 1 minute to explain this. Sorry, some seconds. So this is a pictorial representation of the units and how they work. Input unit will send an input to the control unit. So this control unit is a central processing unit. Once central processing unit gets the input, it processes it, and then it might decide to store it if it's necessary or give output. Memory, if we have the time, we'll talk about memory and how it works. So we proceed. We know of input devices, so I won't waste time there. Are we still there? Hello?
Yes, sir. Sir, we are here.
Yes, we're hearing you.
Okay. So let's. Okay. The central processing unit. Most times when you hear central processing unit, you hear something like processor, but people do get confused when they hear CPU, and then when you look at the old desktop, that computer that sits on your desk that has the monitor and all of those, so people confuse the box. Yes, from time immemorial we are used to saying, okay, the box is the CPU, central processing unit. It's called CPU because the concept is the processor that is the primary, that is the king in that box that you always see. So but then that single device is the central processing unit. That single device is a tiny device, just as you are seeing on the screen now. It's called processor. It's the one that does all the mathematics calculations on the system. So it's the one, when you type A, B, C, D, it's the one that now processes to know where to put A, where to put B, where to put C, and all of those. So this device is more like the heart of the system. So anytime you hear about central processing unit, the first thing in your head should be a processor. So this is a typical processor and how it looks like. Don't forget, you can always ask questions where you don't get it clearly, and as we go on. Okay, CPU component. We are not going to look at CPU components for this class because we might be wasting our time on that. Okay, so primary memories. So when you hear of memories in computer, I want you to understand one thing. There will always be two types of memories. There will always be the primary memory and the secondary memory. Now, why do we have to divide it into two, the primary and the secondary? Because I want to start with the primary memory. You've been hearing of something like RAM, like random access memory, read-only memory. Those are primary memories. And let me tell you how they work. So when your system starts, for example, when you put on your system, since it's making use of instructions, remember we talked about software, that there are sets of instructions. This set of instructions are stored somewhere, so that when you press the power button, the system now fetch those instructions from where it was stored, and then now start making use of those instructions. What did they say I should do? Okay, this one I've done, ticked. What did they say I should do next? Okay, I've done this one, tick. That's the system is processing those instructions. Now, when your system is off, those instructions are stored somewhere, and that's where we call those instructions are stored in the hard disk. When your system comes on, the system had to copy those instructions from the hard disk to another form of memory. Remember, hard disk is a typical example of memory, but it's a secondary memory. Now, why is the system not taking those things from the hard disk and process already? Because hard disk doesn't have the speed that the system needs to process this thing with. This occurrence happens in nanoseconds. Some of you that did physics, when you break seconds into milliseconds, you keep breaking seconds into exponential zeros, you get to nanoseconds. That's minus 0.0000. So now the speed is in nanoseconds, the speed that the system used to process. Now, hard disks cannot withstand that speed. That's why the RAM comes in, random access memory. So RAM can withstand the speed. So the system will now copy those instructions from the hard disk and put it on the RAM, and then start fetching it from there. I want you to look at it from, let's come to physical areas. Let's say you have a site that they are doing construction, a construction site. And in that construction site, you have a small warehouse that you keep your working tools. But then, when you want to close for the day, you pack those working tools, take them home or somewhere that will be safe. When you're coming in the morning, you now bring the box, keep the box somewhere. Like, you won't want to, at each time you need a tool, you go home and carry one and come back. You form a box and keep those tools. At the end of the day, you take that box back to your house. I want you to see RAM and secondary memory that way. Secondary memory is your house, which these tools are safe. That's why you have to carry it away from the site each day and go and keep at home. Primary memory is the box that you took from home that contains your tools to the site, because it's closer for you to just go there and pick a tool and use and return, pick a tool and use and return. That's how computer handles, that's how RAM and ROM works. Sorry, primary and secondary memory works. Okay, if you want to dwell on that, we might go far, but if you have any question, you can throw at that point while we proceed. So we've talked about primary memory. This is a typical example of hard disk and how it looks like. Flash disks. Okay, so this is another part that is important for us to look at. Units of measurement in computer. Why this is important? Remember, this is more like a masterclass, and I try as much as possible to tailor it to what you need, not just giving you jargons. Why you need this one is, one, for example, let's say you're a decision maker and someone comes to tell you, oh, Oga, we need 5 terabytes of hard disks on that system. You should be able to understand what that person means, so that the person will not tell you we need 5 terabytes when you don't even need one. These are some of the reasons, these are some of the advantages of trainings like this. So we won't skip this. We'll dwell a bit on here till we understand. Meanwhile, along the line of this course, we'll be asking questions, and some of the questions comes with incentives. If you answer it correct, you win a prize. I won't say what the prize is yet, but we figured it out already. So let's proceed. So now, computer, how does computer store information? Computer store information in zeros and ones. That's very confusing, we know already. So I don't want us to go into that in details, since we're not teaching a computer science class. But I want us to move a bit to what we call byte. Now, byte, it's 8 bits that makes a byte. So in computer, when you type letter A or you type number 1, it's converted to, that number that you type or that letter will be converted to zeros and ones. How many zeros and ones would this number be converted to? Mostly it will be 8, 16, 32, like, but in the multiples of 8. So now a byte is supposed to be 8 bits. What does 8 bits means? If you come to this first table, we say bit is 0 or 1. Let me see if I can get a writing material. You won't be able to see, but let me try as much as possible to explain this. So if bit is zeros and 1, it means if I have 4 zeros and 4 ones, that will be a byte. That will make a byte. And if I type letter A, the way the computer sees that letter A, the computer will see it in zeros and ones into 8 places. That's, it could see it as 0 1 0 1 0 1 0 1 or 1 1 1 1 0 0 0. Just that combination. That's how computer will see that letter A that you press. And that's supposed to make a byte. So when you hear a byte, think of it as one character, either a number that you press on your system, on your keyboard, or a letter that you press on your keyboard. Then we now go up a bit. In primary school, we used to do 10 millimeters, make 1 centimeters, 10 centimeters, make 1, all of those. The same thing applies in byte. So if 1 byte is 8 bits, yes, that's sorted out already. And then we now look at kilobyte. So kilobyte now becomes 1000 of a byte. 1000 of anything will always be kilo. We know that one already. But you always see 1024. This 1024 explains, what could explain this 1024 is the fact that computer deals with memory in 8 bits, in multiples of 8. So we say 8 times 8 times 8 times 8 times 8 times 8 times 8. But this is theoretically. Practically, you won't still be wrong if you say 1000 bytes makes a kilobyte. But theoretically, you always see the number 1024. Then megabyte. Megabyte is supposed to be multiples of 1000. That's 1000 times 1000. That's 1 million of a byte. It's supposed to be megabyte. Let's pause there and look at what we mean. Now let's go to kilobyte and understand what we mean well. If we say 1 byte is a character that I type on the system, so that means a kilobyte would be more like approximately 1000 characters. And just in case you're explaining this to someone, you must always try as much as possible to add approximately, because you cannot just say 1000 kilobytes. Sorry, 1000 bytes makes a kilobyte. It's better to say approximately 1000 bytes makes a kilobyte, because of the 24 that will always be there, because of the multiplication of 8. Then megabyte now means it's going to be 1 million characters that will make 1 megabyte. Gigabyte, the same thing, multiples of 10 10 10 10 10. Terabyte, multiples of 10 10 10 10 10. Okay, so now the next concept that I want us to look at is image. So if we know that one character that you press on the keyboard is 1 byte, how about image? Image in computer, how much time do we have? We have like an hour and a few minutes, so I can still go. So image in computer basically means a combination of small dots that's called pixels. So each of those dots represent a byte. Without marker and board, it will be difficult to explain this particular image concept for you to understand, and for you to be able to see an image and try to estimate the size of that image, or what size that image could be. So we'll pause that one and then proceed for now. So let's go. So we talked about the sizes. Now, still around the sizes, if someone comes and tell you, oh, your system is using 4 gig RAM, what does it mean? Anybody with idea? After what we've said, if someone comes to tell you your system is using 4 gig RAM, what does it mean for your system to use 4 gig RAM? What's the implication? What do you think it means?
I think it means the processing unit is 4 gig.
Okay, so thank you for the attempt, but yeah, so we are here to learn, and I like when you attempt to answer, because the whole essence of learning is there's what we call learn, unlearn and relearn. So that's why we are here. Now, that's not completely correct, but what it means is your system has 4 gig of RAM. That means, and we talked about softwares as instructions that the system will copy from the hard disk and put on the RAM for it to use immediately while the system is still running. When your system shuts down, when you're shutting down your system will copy those files back from the RAM and to the memory. That's why RAM is not a permanent storage. Hard disk is a permanent storage. RAM, anything that is stored on RAM goes off once your system is off. So now it means when we say your system is 4 gig, let's say this okay, I want you to understand it this way. Your system needs to copy instructions from the hard disk, and these instructions are about 4 gig, no, about 8 gig. So now it means your RAM is 4 gig. The system cannot copy the 8 gig completely into 4 gig. It won't work. So what will the system do? It will copy what the RAM can carry at that moment, and once it exhausts that, it goes back and it will be going back and forth. This back and forth is done in milliseconds. Now, because there's no much space, it will create a slight delay when the system is going back to copy from the hard disk into the RAM to process it. So when they say your system has a RAM of 4 gig, it means the capacity of information that your RAM can store, the memory on your system can store for immediate use, is 4 gig. Definitely it won't be complete 4 gig because there will be slight differences which will make it less than 4 gig. But when you say you're using a 4 gig RAM, it means your system cannot that memory cannot accept anything more than 4 gig data that is being sent from the processor more than 4 gig. So that's what it means. We proceed. Units of measurement and speed. So we'll talk about this. Now, why I take time to explain this thing is if you're in the position of making decision, because that's why we call it ICT for business. Because somehow you'll be in a position to make decisions. All this information will help you. So units of measurement. This takes us back to the processor. For some of us, whichever one, that did physics in school, something like frequency is a familiar word. Now, frequency is measured in. Please, who can tell us the unit of frequency? I think I still have some science students on this class. Let's make it interactive. Who can tell us the unit of measurement of frequency? For example, let me explain what I mean. If you want to measure weight, they say it's in grams, kilograms, and all of those. If you want to measure frequency, what unit do you use? No answer, no attempt.
I don't have ideas, so I'm not a science student.
Well, we should have science student now. No science student on this call. Hey, too bad.
Frequency is measured in hertz.
Okay, so the unit of measurement of frequency is in hertz. So now, how does hertz come into computer now, and how does frequency comes into computer now? It's your processor, the processor that's the heart of your system. I think it will be best understood if we use human heart to explain this. Now, as humans, whether you see it or not, whether you feel it or not, your heart is pumping at a particular rate all the time of your life till the last breath. Your heart will be pumping.
Yeah.
So now that pumping is sort of like just like something is going back and forth, going up and down, going back and forth, up and down, up and down, up and down, up and down. Now, That's frequency. The time that it takes to complete a particular cycle, it's called frequency in science. So now your heart is pumping at a particular rate. It's going up, down, up, down, up, down. The same thing happens in processor. In as much as processor is not pumping up, down, up, down, up, down physically, but the time it takes that processor to complete a particular task and go back to the next one, or go back, repeat that task again, is measured in hertz, because frequency is measured in hertz. So 1 hertz represents a cycle per second. It will be cleared by the time we proceed. So now, if you want to go and buy a processor, if you want to buy a system, they will you start asking, or they will start asking you, what processor do you want? I know some of you are familiar with some stuff like this is not the era of Pentium again. I think those era you were familiar with Pentium 1, Pentium 2, Pentium 3, Pentium 4. Now you may be familiar with Core i1, sorry, not Core i1, Core i3, Core i5, Core i7, Core i9, all of those. Now, outside the cores, which if we still have time, we'll talk about the cores. Outside the cores, if you want to buy a system, you want to look at the speed of the system. So I want us to do practically for 1 minute. Let's see what we can do. Please, who is using a Windows laptop and is on this call? Can you identify, please? If you're using a laptop and it's Windows, please identify.
I'm using a laptop.
Okay. What type of Windows are you using?
I'm using an I just got it, so I don't really, I think 7 or the 8, I don't know.
Okay.
But it's called iCore 7.
Do you know how to share your screen? Would you want to share your screen? Okay, I'm back. So I've been able to pull up what I needed to see from your system. But this is not from your system, mind you. I just picked the image from online.
I would have shared my own screen so that they will use.
Can we get this point? It's only when you share Windows that we can get this point. So I don't know if you can attempt sharing Windows, but then since we've already gotten here, that's fine. There will be no point for that. So I want to explain this as regards to what we mentioned on the slide. So I'll be switching the slide and this. Okay, so we were here. Remember, before this point, we had talked about storage sizes. That's what we want to look at practically. Scene 2. Okay, so this is a typical specification section of your system. So when you're buying a new system and someone is asking you what's the specification of the system, this is where you go to look at the device name. This one is irrelevant because it can be changed. The processor. So let's look at the processor. What you're seeing, let me confirm you guys are seeing me. What's written on the processor, please? Someone can volunteer to read it for us. Thank you.
Okay, for the processor, I'm seeing Intel Core i3 606U CPU at 2.00 GS 2.00 GS.
Okay. So let's go over each of them and explain. So under processor, we have Intel R Core i3-6006U CPU at 2.00 gigahertz. Now, it means the speed of this processor is 2.00 gigahertz. So from what we did previously, how many hertz are there in 2.0 gigahertz? Who can volunteer?
How many what?
Hertz. HZ
Yeah.
are there in gigahertz.
Okay, gigahertz.
I didn't get the question, sir.
Okay. How many bytes are there in gigabyte?
We have 1,024.
No, that's kilobyte.
Okay, for the gigabyte,
Yes.
1,000,000.
20,000.
No. That's
That's one
2,000.
no gigabytes, 1,000,000, right?
How many bytes are there in gigabytes?
So I don't know.
It should be, is it 100 million?
Okay.
No,
So,
100 million?
so let's do it this way. We said
That's 1,000,000.
1,000 bytes. 1 kilobyte is 1,000 bytes. 1 megabyte is 1 million bytes. After megabytes, we have gigabytes.
Gigabytes.
So it's 1 million times 1,000.
That's 1,000,000
That's
times
10
That's
10
1,000 million.
Say 1,000. Who said 1,000 million?
That's 10 million.
No, that should be 1 billion.
Is that 1,000,000,000?
Yes.
It's 1 billion.
Okay, yeah, please.
It's 1 billion. It's 1 billion. It's 1 billion.
So, with that, we can now understand this well. When we say 2.0 gigahertz, that means we are saying 2 billion hertz. Now, 1 hertz is 1 cycle. So just think of a cycle as you turn a light switch from up to down. That's 1 cycle. So if you keep turning up, down, up, down, up, down, up, down, up, down for 2 billion times, that's the strength of the processor that this system is using. The system we are showing this view, I picked it online. So that's how you look at the speed of this. 2.00 gigahertz stands for the speed of the processor, how fast the processor can process, information. So if hertz is in seconds, like a cycle per second, it means this processor can go 2 billion cycles in 1 second. Are we clear?
Yes.
Okay.
Yes, sir.
I want to be sure it's not confusing. So now, let's say you see 3 here, 3.0, and you see your own is using 2.0. You see someone else is using 3.0. The implication is that person's own can does computer processing, can go 3 billion cycles in 1 second, while your own can go 1 billion cycle in 1 second. That's how to know the speed of a processor. And when you buy any system, you always see this information. So we proceed. We can just come back a bit. Intel Core R. R means it's a registered core. It's a registered core. Core is a trademark of Intel. So that's why you see Core TM. i3. So now they started when Intel were done with Pentiums, they now started rating cores in what they call and they put numbers. So the higher the number, the higher the cores. So I feel it will be dragging us back if I start explaining what cores represent. So we'll leave that one first. And then you see the number and all of this. So we move to installed RAM. So this is the random access memory, the primary memory we were talking about. So in this system,
sorry, I have a question.
Okay.
Before we go to this, this processor, like this one you are showing, has a 2 gigahertz. So my question is, for a good laptop, if someone wants to buy, like what figure can we be looking at that we can say, okay, it's recommendable, it's okay?
So
I want to buy.
From 2.00 gigahertz is a very good, is from 2.0 upward is good, is a good speed for a laptop.
Okay.
Yes.
Okay.
Though there are some desktop you can see they'll be running like 4 or 5 gigahertz. But for laptops, you start seeing laptops maxing at 1.8 upward, and some of them max out at 4. So 2 is average. 2.00 gigahertz is average, like it's relatively okay. We can proceed, right?
Yes, sir.
Okay. Then installed RAM. We now see 4.00 gigahertz. What this means is it can store 4 billion characters at a time for the processor to use. I think here is the right place for me to do that explanation again. This is processor, this is RAM. When your system starts, this processor goes into action, pack information that it will need from your hard disk and dump them on this RAM, just for the purpose of when that system is on. Once that system is off, the information that is on this RAM is gone. So when we say our RAM is 4.00 gigahertz, it means it can accept 4 billion characters from the processor at a time. That it can fetch out 4 billion characters from the hard disk and store on its head while the system is still on, and be giving it to the processor back and forth. So that's it for this. And then the other one is the hard disk size, the secondary storage. I guess we all know how to check that, how to look at that, and how to size that up. Is that correct? Do we need to do that, show you where to get that, and show you example of that? I don't think we have the time, so we proceed to something else. Okay, so we are back here. So the CPU speed measurements, 1 hertz, 1 gigahertz is 1 billion cycles per second. More. Why?
issue.
I think he just left. I think it's his network.
Mm.
You can still hear me, right?
Okay,
And
I think he's back.
he's back, but
Sir, are you there?
I'm back.
Okay.
Okay, so 1 gigahertz is 1 billion cycles per second. Just like we said. So when you see your processor is having 2 gigahertz, it means it can complete
2 billion.
2 billion cycles per second. So we proceed.